Now let's try to study a little bit more about the transformer and how does it work. So in the previous slide, I say that simply determine the number of the turns in the loop. You can either try to boost or lower the voltage. But how does it work? So now let's try to take a look about these pictures. So this is our primary loops. This is a secondary loops. So the number of the primary loops, let's say give you a number, hundreds. And the number of the turns in the secondary loops, which is 10. So this primary loop is connected to the high voltage. So you can consider this is the input voltage. So the current will flow into the coils. And we learned that in the previous lectures. If you have the current flowing in the loops, then you will produce a magnetic field. So this magnetic field will passing along the irons and entering into the secondary loop. So therefore, the change of the magnetic field or the change of the magnetic flux is the same for both loops. So why this is important? Now let's review our knowledge of the Faraday's law. So what Faraday's law tells us is that if you have a voltage induced, the number will be proportional to the number of the loops or the number of the turns multiplied by the change of magnetic field with respect to time. So we have argued that this term will be the same for the primary coils and the secondary coil. Now the number of loops is different. So therefore, by simply determining the number of loops, you can decide how big of the induced voltage. So therefore, try to write down what we just say in terms of the formula, the relation. So the primary voltage is the input voltage divided by the number of the primary loops or the primary turns. This ratio is equivalent to the voltage across the secondary loops divided by the number of the secondary turns. So therefore, if you have hundreds voltage in the primary voltage and you have 100 of the turns, then simply by determining the number of the secondary turns, let's say 10, then you can determine that now the voltage from the secondary coils is 10 voltage. So now the voltage is lowered from 100 to 10. So now let's try to write down this relation in terms of the variable. So you can see that this relation looks a little bit different, but it is still the same formula. What he say here is that the voltage across the primary divided by the voltage across the secondary, this ratio is equivalent to the number of the loops along the primary loops and the second loop. So this is just different way of saying the same thing here. But the reason I try to write down the equation in terms of this formula is because we know that induced voltage actually is related to the induced current through the Ohm's law. So therefore, the magnitude or the ratio of the input and output electric current is actually determined by the number of the loops. But I have not, so let's take a look about the example of the transformer in our daily life. So this device is actually a transformer. What it does is that it transforms the energy, or I should say, they lower the voltage from 120 volt to 6 or 9 voltage, depending on your device. Also, they convert the AC current to a DC current. So this is the one you use to charge your laptop or the smartphone. So it is a transformer. Another common transformer is this one. Probably some of you never seen this before. So here it is a power line from power plant. So this voltage along the power line is around 2400 voltage. And this one can lower it to 240 voltage. So they just using different device try to lower the voltage difference. But I only explained how the transformer works, but I did not give you an explanation why we need the transformer to transmit the electricity to your house. But I will give you more details and introduction on that. Before that, let's have our first conceptual quiz today. So what can the transformer do in a circuit? The answer is voltage difference. So they can lower or boost the voltage, but they cannot change the energy. Energy is conserved. Energy entering to the primary loop will be the same energy out from the secondary loop. So energy is conserved. So in order to provide you the explanation why we need the transformer, when we try to pass the voltage from the power plant to your home device, we have to introduce you this concept, which is the electric power. Actually, we already learned the concept of power before. It is the energy spent per hour or per second, depending on the unit. So the electric power is actually the voltage drop multiplied by the current. So remember, it is the voltage drop. So for example, if without the voltage drop, if the current passing through the power line and the voltage is always 100 voltage, there's no voltage drop, then in that case, the electric power is very small. So the electric power is determined by the voltage multiplied by the current. So now let's assume that in an ideal situation, we can neglect the heat lost during the process. So now the power entering to the transformer in the primary loop will be the same as the power out of the secondary loop. So voltage multiplied by current in the primary will be the same as the voltage multiplied by current in the secondary loop. So now, based on this fact, I can give you the explanation why we need to use a transformer to boost the voltage to a very high voltage. The reason is that when the voltage flowing, when the current moving in the power line in the very high voltage, the voltage drop is very small. However, so in that case, we can basically ignore the effect from the voltage. But from the Ohm's law, we know that the Ohm's law is the current multiplied by the resistance. So now we can replace this one by the current multiplied by the resistance and multiplied by current. And we know that the resistance of the power line is a constant. It just depends on the material. So which means that how many energy or the power will be lost will be determined by how big the current it is. So our purpose is try to lower the current propagate when we transmit the electricity to your home device. So we know that the bigger the current, the smaller the voltage. But now we try to lower the current, so which means you have to increase the voltage to as high as you could. So that's the reason we need a transformer to transmit the energy. So what you are doing is that from a power plant, you will produce an induced voltage. And you can see here it is only about 12 kilovolt. Now, when you try to transmit, you have to boost that to a very high voltage. So therefore, from 12 to 400 kilovoltage. So in that case, you try to minimize the energy spent during the transmission. And now, before they enter into your device, they have to passing through different kind of transformer, such that they can control eventually what is the voltage entering into your home device. So that's the reason we need the transformer. And this is the picture you are going to see frequently in the daily life. So this is normally next to the power plant. And this is probably in the wild field, you will see this one. But within the city, this kind of power line are already embedded underneath of the road. So this reason you cannot see that, but it doesn't mean it is not there. So finally, we are talking about the electric field inductions. So I told you that first, if you have the electric field, you will produce a B field. But now, from what I just discussed to you, if you change the magnetic field, you can produce an induced voltage. But what is the voltage? Voltage actually is related to the electric field. So therefore, once you change the magnetic field, you also induce an electric field. So here the whole picture is that if you have an electric field induced, you definitely also will have the magnetic field induced. So that always happens. So when I say induce, I mean they change with respect to time. So simultaneously, if there is a magnetic field induced, you also will produce an electric field. So they always appears together. And this one is a very important fact, is that because we are going to study about the light in the following chapters. So what is the light? Light is the electromagnetic waves, and it is composed of the electric field and the magnetic field. And it is the oscillation of the electric field which accompany with the oscillation of the magnetic field. Together, they will produce light and they will propagate in the space. So this is a very important concept. The electric field and the B magnetic field, they all produce together. They are not separate concepts. And they are all part of the light. So now let's have another conceptual quiz. So therefore, the answer is the light. No matter you induce an electric field, magnetic field, once you induce one of them, you produce another one, and then because of a fluctuation of that, you can produce the light.